In physics problems, we're often told to ignore air resistance. But what really is air resistance, and what happens when we don't ignore it? Well, air resistance is just the drag force, which can be described by this equation, where Fd stands for the force of drag, rho is the density of the fluid, or in this case, the air density, v is velocity, which is squared, c sub d is the coefficient of drag, and lastly, a is the cross-sectional area. Notice how air resistance doesn't depend on mass or how much an object weighs. So let's say you drop an orange from a certain height. If you wanted to find out how long it would fall for, you could just use your handy-dandy kinematics equations. But what if you factored in air resistance? That's when it gets a little trickier. Air resistance depends on velocity, which means that the acceleration is not constant, and the equations you're so used to in free fall motion no longer apply. Uh-oh.